All right. I just have day 3. So the first thing we want to talk about is data types. So I'm going to just go ahead and work in the shell for the time being. To give us a little more space, I just changed the layout to make it stacked instead of on the sides. So hopefully this gives us a little bit more room to work. That still looks funny. Okay. So the first thing we talked about is, let's just say we have the number 2. Is that large enough for all of you, number 2? All right. So if we have number 2, nothing fancy, what type of value is the number 2? Is it a float, an int, or a string? It's an int. So again, remember a REPL is just going to read it and it's going to evaluate it. It's just a number, so it's going to just print out the 2. But let's suppose as we get more types of values, we're like, hey, what is this thing? There's a function called type. So if I just type the word type, and type takes an input of some object or value. So if I type type and then I put in parentheses the number 2, it's going to say, hey, this is a class it's from the class known as an int. So we can verify that. So we also went ahead and considered what happens if I put a 0.0. Does anyone remember what type 2.0 is? It is indeed a float. We also encountered another type of type, and let's go ahead and put in quotations quote 2.0. And we got to be careful here because notice this is a quote. If we're quoting it, what type of data type are we working with? A string, and you can see that right there. So be careful. The double quotation marks are indicating that this is a string. By the way, I can't remember if I said this formally, but in Python, it does not matter if you use single or double quotes. So if I also just kind of did the same thing using single quotes, it will work out nice. There was a little bit more on that in the more on print exercise that I left you. So again, just wanted to make that clear. And if you have yet to do that, make sure you do that before midnight tonight. So we also talked about, let's say we were, we're doing some financial things coming up. So let's say you're going to the dollar store, which is never a dollar anymore. So I think I just read like the dollar store is now called like the dollar and the quarter store. So let's say we have a price right here and we put it in quotes 1.25. So I'm going to go ahead and store that in the variable price. And again, if we look at, let's say we stored something in price and we want to see, hey, what is the data type that is being stored in price? You can just pass in a variable like so, and you can see, oh, it's a string. But does anyone remember what happens when we added strings? Like if I went ahead and added to price an exclamation point, does anyone remember how do strings behave when you add them? Does anyone remember the operation? It's combine, or the word that the technical word is concat. So it concatenates the string. So again, just remember that right there. But let's say like, hey, you're at the dollar store and you're like, I want like, I don't know, does anyone just like love going to the dollar store? My wife does, and she'll come back with like a dozen things. So I'm like, okay, how much did you spend? So price times 12. Does anyone remember what happens when you multiply strings? It just repeats. So that is not a very helpful answer when we're budgeting. So we have to keep in mind, be very careful when it comes to the data type that you're working with. So what we can go ahead and do, let me go ahead and no, it doesn't work so like that. Can you all still see at the bottom, Caroline? Is that fine for you? Okay. So what we can go ahead and do is known as cast. What we can do is cast a string to a float. And as long as it's of as long as it's an appropriate string, it'll be able to change the data type. So what I'm going to do is I want to update the price to be a float. So this float right here is now acting as a function that will take some sort of input and try to turn it into a float. So you can now see price. I'm going to make it a float, and you can see now instead of it being a string, it is now a float. So let's just, one of those things about programming, as you come across these questions, try it, see what happens. So the question is, what if we had, let's say we had price 2, and it was like $1, and I tried to make it, let me actually make price 2 like $1.50 or whatever, just to illustrate this. And if I tried to make price 2 and I tried to make it an int, let's see what happens. So let's make it an int, price 2. You can see that it does throw a value error because it doesn't know what to do with this decimal. So this is something to experiment with a little bit right there.
Mine just made it 1.
Did I mistype something? So did you cast your first price? So if you were to go ahead and take price and now try to cast a float to an int, it's going to drop the decimal.
Okay. Yeah.
So in this case, notice that price 2 is $1.50, and I tried to say, hey, make price 2 an integer. It didn't like that because like this is not an integer. But if you tried to cast a float to an int, it's going to just apply the for function, basically. It's going to just remove that.
Okay.
So be aware of kind of these little nuances, play with them, and things like that. So that's a good thing to keep in mind. Again, we have a couple different scenarios on the main ones we're going to cast to. And I'll post this later because we can't save that side. But the main thing that you could think about at this point, their appropriate data types can be cast to another data type using the functions int, float, or str. So if you have a number and you want to think about it as like, I just want to repeat this number, like printing it wise, you can cast it to a string. You also have that right there. Okay, so let's keep that in mind, and let's go ahead and talk about, let's go ahead and make a file called input.py. I really didn't mean to assign that exercise 3 until after we talked about input, so we're going to do that right now. So let's go ahead and get a file. Let's go ahead and just name it input. Actually, hold on. Will this work? I'm going to just go ahead and do it this way. I'm going to just work in main. The reason I'm going to do that is so that I can just use that run button on top. That will be easier than constantly typing, but we've done it in a few days to go ahead and get used to that. So hold on. I don't know where there it works. Okay, so I'm going to just work in main. So let's go ahead and talk about the input function. Let's declare a variable called your name. And before we just typed in, before we just did okay, my name's Cody, so I typed that in. But what if I want to ask the user of the program what is their name? So we're going to dynamically assign variables at runtime. So again, before we hard-coded it in, what we're going to do is use the input function. So I'm going to type the word input. Functions take input, so I'm going to go ahead and put a parentheses. And the input to the input function is a string that you want to display to the user. It's a prompt. So of course, okay, this program we're just kind of ask about their name, so we're going to just say, not yes, but what is your name? Let's make it a question. All right, and so it's going to ask the name. Let's make it a polite program. So what we are going to then print back to the user is hello. And remember, there's a couple different ways you can do this. I'm going to just apply more than one input to the print function. So I'm going to say hello, your name. So let's go ahead and run that. And you can see it says, what is your name? And it's just kind of stopped there. And what it's doing is waiting for me, the user, to type my name. So I'm going to just type Cody. And then I'm going to hit enter, and it's going to say, hello, Cody. And again, the formatting's a little bit weird, so I may want to put a question mark and a space. So you can see it's a little bit cleaner. That when I tape what is your name, it's going to respond like that. So this is a way to give input to the program of the user dynamically at runtime. All right. So let's go ahead and explore this idea a little bit more. So let's go ahead and your age, input, how old are you? Question mark. So, and then we'll just kind of keep this conversation going. Oh, you are your age old. But what I typed here, well, actually, let's not spoil it. You may have caught the intentional bug I left here, but things to remind you. So if I run this, it's going to say, what is your name? I'm going to say it's Cody. How old are you? 97. I look great for my age. But look what it said. Oh, you are your age old. So did anyone catch the bug here?
You left it inside.
So it's fine inside. But remember, when we put these curly braces in here, we were going to use a special type of string, an F string. So remember, if you're going to use this syntax to basically put variables into a string, you do need to put F in front of the quotation marks. So if I put F in front, it is now an F string, and notice how it changed the syntax highlighting. So again, this is just a reminder of F strings. These were introduced in Python 3.6, thank God. It makes readability much easier. So you can now see Cody, and then when I do, how old are you? I'm 97. Oh, you are now, and notice it took the variable and put it in the output. That was pretty. Any questions so far? Okay, so let's go ahead and keep this conversation going. So older age is your age plus 1. So there's going to be some computation done in the background that the user is not aware of. So let's go ahead and just say print, and I'm going to pass in a F string and says next year you will be, just in case I didn't know, older age. So let's go ahead and run this and see what happens. So run. My name is Cody. Yeah, Kenneth?
So you named your variable old age, but then you put older age.
Well, and notice, let's see what happens. Well, a couple things happened. First of all, I'm getting a type error, and you're going to find that you're going to make typing mistakes all the time. And make sure you're always reading these errors right here. So yeah, let's go ahead and just correct that. I got an error. If you read it, this might be more indicative of what's happening, but let's try it again. Cody 97, but I'm still getting an error. Even though I fixed that, I'm still getting an error. Go ahead and read. What is the error? Go ahead and.
You can only concatenate strings, not.
So the thing to note, you are inputting a string. But if you want to do a computation, you do need to go ahead and actually make an adjustment to the input, and that is say you should go ahead and cast it. So what we're going to do is make, let's see, older age. So what we're going to need to do is make this an int before we add 1. So be aware of the errors. If you tried to add a string and an int, it's a type error because those things aren't supposed to be added. But now if you do this Cody 97, I don't know why I decided on 97, and say next year you'll be 98. All right, let's use this opportunity to also talk about a couple different other ways to increase your age. Why would you wait 365 days when you can just go ahead and type a line of code? So what we're going to go ahead and do is, so older age, so let's go ahead and do it one more time. Older age is going to be older And I kind of did this earlier. I just want to kind of put one in a scenario where you'll kind of have it for reference later. So this is a kind of common syntax to say, hey, I just want to increment the variable y1. Older age is currently stored value plus 1. So I could just say print the following year you will be older age. So this is me just kind of showing you some syntax stuff. And let's just run this and see if everything is doing what we expect. My name is still Cody. I'm still 97. But you can see next year you will be 98. The following year will be 99. So it's just incrementing it. Is there any questions so far? Yeah, Caroline. Say that again. So the question was, why didn't we put int in front of this older age, basically? Is because realize that how we're kind of flowing through this. The program asks the user for their age. We tell them. And again, we print it here, so we didn't need to do any sort of casting. But the program needs to do some computation. So here, it needs to turn your age into an integer before it can add it. But think about what is older age right here. It's a variable that, and what is the data type of that variable? It is an integer. So the older age is already an integer, so we don't need to cast it again to an integer because it is already an integer. Typically, keep in mind whenever you're asking a user for input, you're going to need to cast to appropriate data type. All right, and maybe one more kind of syntactic thing to be aware of. Older age, and if you do plus equal, this is basically shorthand for what we just wrote above. That I'm going to take older age and increment it by some number, and I'm going to say 2 just to illustrate it. Doesn't need to be 1, but this is the same as older age equal to older age plus 2. So it's just kind of such a shorthand notation to help us out. So print 2 years after that you will be older age. And again, why is this not white? Why is this orange, kind of indicating that something's maybe a little bit weird? It's not an F string yet. It's just a standard string. So in order to go ahead and apply variables inside strings, you need to make it an F string. So this is this is a little example of inputting. So does anyone have any questions on what we went through here? If you want to kind of run it one more time to make sure there's no bugs. Cody, 97, or I guess I'm 9 years old now. So you can see this right here. Any questions there? Okay, one thing that I'm going to caution you about is this will probably happen to you at some point, and you're going to be like, everything looks fine. Why am I getting this error? So remember, we should name, I'm going to just do this in the console, so just down here below. Remember, we should name variables kind of as a reminder of what they are. So maybe you're not sure what the input is, so you're like, oh, input is going to be input, and I'm going to just say, how old are you? So we're in the shell, so we're in a REPL environment now, so it's going to read that, evaluate that, and it's evaluating, asking us the question. And let's go ahead and say 9. So if we do this, everything looks fine, because we can go ahead and print the input, and it's 9. But what happens now if you go ahead and say something along the lines of like, oh wait, okay, I didn't like that input. I'm going to go ahead and ask for input again and say, are you sure? I'm going to just pose a question, and I get this. Everything looks fine, right? I'm like, why? I was expecting it to ask me, are you sure? anyone want to take a stab at what happened that caused this bug? So input already has a name. So by using a variable called input, we basically overwrote Python's implementation of input. So all of a sudden, that is no longer accessible to us because input is a function. What we did here is made input a string. And all of a sudden, we no longer have access to Python's implementation of input because we decided we're more important. We're going to make input equal to this. So.
How they didn't allow you to name variables and stuff like that?
Well, it's going to allow you. Okay, so careful. Let me kind of comment. It's going to allow you to do input. The ones it's not going to allow you to do are these right here. These right here are not functions. These are special words in Python that are going to tell the program to do something. So like for example, let's see what's one we've run into already. We haven't run into a lot of these yet.
I've run into else.
Yeah, so we're going to talk about else today. But these are so yeah, we don't have these yet. But these are special words that are going to help us flow through the program. So input is not a reserved keyword, so it will let you overwrite it. That's something known as function overloading or method overloading, which we won't talk about now. So you technically could basically say, hey, I want my own implementation of this. But that's outside of the scope of where we're at right now. But so we'll probably get to that when we talk about object-oriented programming, overriding certain functions and things. But good catch, good observation. So any questions on this one right here? All right, just to make sure you have a chance to get it practiced, let me give you a couple, maybe like 2-3 minutes to do a little exercise. So the exercise is a little bit of review from last time. Write a program to compute the radius of a circle. That's not the correct word. To compute the area of a circle. There will be 3 variables, pi, radius, and area. Choose an appropriate value for pi. Ask the user this time for the radius. If you remember last time, we just went ahead and hard-coded it, and then the area should be computed appropriately. And then go ahead and print the area. Let me give you a minute there to try that one out. You can put a new file. You can copy input over to a new one if you want. But again, I'll post all of these later. So if you want, you can just say input. So here's one possible solution, just to kind of give you a few minutes to think about it, experiment with it, but I do want to keep us moving so we could get to a few ideas concerning repetition and branching a little bit later. But very similar to what we did last time, I declare a floating point value for pi. This time I'm going to ask the radius. Here, let me just post, did anyone forget to cast the input to an int? I'm not gonna lie, I forget to do that all the time. But remember to read any bugs or any errors that you get as you debug, but then you can store the area as pi times the radius squared, and then you could print the area. So does anyone have any questions about the the solution or about this exercise? How many got it? Something. All right, very good. And again, you maybe need a few more minutes to debug, but let's go ahead and talk about a couple other math operations that'll be useful when it comes to the financial project one. So I'm going to just kind of show them here, and then we'll experiment them with them a little bit. So there's two other operations that we didn't talk about before. The first one is going to be the integer division. So it's denoted with two forward slashes. So if you look at this one right here, this is the division we're used to. If you were to type this 4 divided by 2, it's going to go ahead and give you just 2.0. But if you go ahead and do 3 divided by 2, it's going to give you 1.5. It is a float. So interdivision returns an int by dropping the fractional part, very similar to what you would have done if you just cast a float to an int. So you can see right here, 4 divided by 2. But if there's 2 division signs, it's going to just, this is actually a little bit of a typo. That should have been a 2 right there. And again, you can verify this. But if you do 3 interdivision with 2, you're going to get just 1. It's going to drop the 0.5. So this is very, very good if you don't care about the quotient. So let me just kind of throw that out there again. If you don't care about the quotient, excuse me, I shouldn't say quotient. If you don't care about the remainder, if you only care about the quotient, this is a good way to just get the quotient without the remainder. But let's suppose you need the quotient and the remainder separately. In discrete, you guys talked about mod, right? You guys did a little bit of number theory. So that's what this right here is. This 3 mod 2, this percent symbol is read as mod. So maybe what you would have seen in discrete would have been something like 3 mod 2. And then this would just be 1 because it is the remainder that you get when you divide 3 by 2. So this is and programmatically, that's how it works. So if you do 11 mod 3, 11 divided by 3, it goes in 3 times, but it is going to have a remainder of 2. Just to make sure the idea, let's go ahead and go ahead and, what's someone's favorite number? 7. Here, let's do 20 mod 7. Go ahead and think about what the answer was, and then go in the shell and go ahead and verify that you are correct. If you think you know, raise your hand. What is 20 mod 7? Anyone think they know? That's for a volunteer. Kenneth? It is 6, because 20 divided by 7 is going to give you a 14 with a remainder of 6. So, all right. Does anyone have any questions about those 2 operations? Okay. A couple other things that is just maybe easier to look at right here is does anyone know what a Boolean is? You've already encountered it. Wait, is everyone here already taken discrete? Is there anyone who has not taken discrete? Okay, well, you took other courses beyond discrete. That's right. So a Boolean is what you guys were typically working on with logic. So it's either true or false. So a Boolean is a value that is either true or false. So what we're going to want to do is find different ways to flow through our code. And we'll do that based off of the logical value of a Boolean, or some sort of that comes from a comparison. So let's introduce the double equal sign. The double equal sign is your comparison. So like and like solving equations, like if you do 5 equal to 6, you would just go ahead and say that this is false. Probably came from solving. There's no solution. In programming, to compare numbers or compare certain data types, you use a double equal to sign. The single equal to sign is the assignment operators, how you bind values to variables. So if you look at a few examples right here, let's actually go ahead and type through these just so we can kind of wrap our mind around them. So I'm going to go back to the shell right here. Let's go ahead and type through some of these. All right. So like if we do 5 equal to 5, this maybe you just forget. This is going to throw out a syntax error because remember 5 is not a valid variable name. But if you do 5 equal to 5, it's going to do true. 5 equal to 6 is going to be false because that is a false statement. By the way, just to figure out like what the type of true is is a data type known as a bool or a boolean. So a boolean will either be true or false. It has a 0 or a 1 value. So a couple things that are interesting to keep in mind. You could cast to a bool. So if you cast the number 0 to a bool, it is false. So if you see, so keep that in mind. If you cast any other integer to a bool, it will be true. So if I cast 1 to a bool, or if I cast 42 to a bool, any non-zero integer is if you interpret it as a boolean, it will be true. There's also going to be you can also cast strings to bools. So if I go ahead and say, what is the boolean of hello? It is true. And let's go ahead and experiment a little bit with, not here, I think just so we get to a certain idea. Is everyone okay what a boolean is now? All right. So let's look at a couple other comparison operators. So let's assign x to 5 and y to 6. And again, if we were just going through and typing all this up, if x is equal to 5 and y is equal to 6, keep in mind this is just a little reminder that double equals to sign is a comparison and a single equal to sign is the operator. So up here we assigned, down here we're comparing the variables x and y. They are not equal, so it's false. So notice that this is how you test if two values are not equal. So x is, and then you do because in math we're fine just doing 5 is not equal to 6, but there's no not equal to symbol on your keyboard, unless if you draw one there, and it probably won't work. But to do that, you'll just need to use this syntax. So you just put an exclamation point in front of an equal, and that is your syntax for not equal to symbol. And you have your standard comparison operators, so your greater than, your less than or equal to, and greater than or equal to. And again, you don't have the standard alligator with a beard. You have to go ahead and just do it as you say it. So I don't think I've ever called a loose inequality an alligator with a beard, but hey, there's a first time for everything. When you compare strings, I would encourage you to kind of type through all of these later today, just to kind of get it into your mind. But again, a lot of these are just verifying things. Two strings, let's say we have ABB and ABC. Of course, these are not the same strings, so that's going to return false. And we have, but if you look at S1 is less than S2, that is true. And we say that string comparison is done by lexicographical ordering. So lexicographical ordering is just dictionary ordering. So this is true because if you were to look at, if ABB were a word and ABC were a word, which one would come first in the dictionary? ABB would come before ABC. So that is what happens when you compare strings. And then the last scenario to note is you can't compare strings and ints. It'll throw up a type error basically saying comparison is not supported between data types. So a lot of today has been about data types. Any questions on the comparison operators? Again, I'll have these posted by end of the day, so feel free to experiment with these. All right, logical operators. This should be pretty clear since you all took discrete or have been exposed to logic. Let me look at the table right here. So you have your basic logical operators that you're used to from formal logic. True, not true is false. False, and if you were to do not false, you would get true. And you have the principles of true and true gives you true, true and false is false, false and true is false, and false is false. And you have a similar one for or, but and or are valid comparators in Python. So you can see a couple examples down here. True and true is going to give you true, and true and false will give you false. So experiment with this. What I wanted to kind of end today with a little bit is branching, because this will allow you to control the flow through your program. So actually, I don't want to spoil that. We're going to go ahead and actually type. Yes, this will all be posted later. Any questions? A lot of this is just a little bit of memory work and experimentation that'll come naturally. All right, any questions? Okay, so let's go ahead and talk about control flow a little bit. So I'm going to just go back to main.py, and I'm gonna, and this is going to help you all when it comes to this this program. Andrea, is it okay if I kind of pull up where you were on your exercise to use as a starting point? All right, so I've seen this, I think Anna and a couple of you who were asking questions about these tests right here. So if you run the tests, these are not passing because what the automated tests are doing are, it is going to, it's basically a separate run of the program. So you can see like, okay, what we're trying right here is like, okay, we know this first one, the inputs are -5, 180, and -17. So maybe if we just hard code them, print the sum, or then add them and print the sum, that'll work great. But that's not the only thing your program is going to be doing. It's going to be doing this one right here. So again, we need to dynamically take input so that it doesn't. So each time it runs, it is going to do the same thing, but with input provided by the user. So let's go ahead and, again, keep that idea going with this program. So let me see, where were I? All right, so I'm going to ask the user, can I have an X? Please, be nice. Yeah, Alejandro.
When you're typing the homework, if you add a text inside the input function, it marks it as wrong as well.
Correct. So make sure whenever you're failing a test, compare what you are getting as output to what is expected. So that's, again, I'm kind of leaving that to figure out a little bit. Yeah.
So we just make it pass. That's what.
Yeah, for automated tests. Yeah. Yep. So let's go ahead and let's say you are a very positive person. So like, you don't want negatives. So like, you are like, if someone tells you like -5, you don't want to repeat that. So what we're going to do is add a keyword if, and this is one that you can't overwrite. This is one of those arguments. So you're going to say if x is greater than 0, then you'll actually talk about it. You're very like, okay, no, I'm not going to say it unless it's negatives. So I'm going to go ahead and print the fact that x is positive. So I'm going to run this, and let's kind of see what happens. So I'm going to run, can I have an x? 5 is positive. But notice, if we were to run this, and let's type in like -9, it's just going to end. It's not going to say anything. It's a positive program. So this is a way to control your flow through a program using something known as branching or conditionals. So keep in mind, like, it's only doing what you said, because technically, if you only want to say positives, You do keep in mind 0 is one of those. It's neither positive nor negative, so you'll have to decide. Be very careful because a very common bug is forgetting an equal to or not, or putting one when there shouldn't be. So be very careful. Like if I wanted to be positive, you wanted to make sure that you don't put an equal to sign because that would be a kind of a corner case that would fail, or at least what your intention is. But what if you're like, okay, fine, I'll tell you if it is negative. But so what we'll do is make an alternative path. So the way to do that is else. So what we'll do then is say, then we'll go okay and say, okay, print, I don't know, fine, x is negative. He's not near as happy about it. It's a very, very positive program. So now if we run this and we do a negative fine, it'll be like fine, -3 is negative, I know, whatever. But he's a little sad now. So if we kind of look at this again, there's that little bit of a scenario of like, what about 0? So what we could also go ahead and do is, let's say we want to handle 0. So what we can do is put L for else, but we're not going to say all of else. We're going to say if. We're going to say elif. Fun word. And what elif is another branch that you could take. So elif x is equal to 0. And I'm going to go ahead and change this. No, here, I'm not going to. Yeah, so I'm going to go ahead and put this. No, that's fine. That's fine. Never mind. Got myself a little confused. I'm good. So print f, let's say good, compromise, x is neither positive nor negative. So great question. So let's go ahead and run this and see if it does what we expect, and then we'll talk about that. So let's go ahead and run. And can I have an x, please? Okay. 0. Okay, that does what I expect. So we do want to make sure that if is asking for a statement that is either true or false. So your question, to make sure I understand, is why am I not putting this?
Yeah.
Because I am not reassigning x to be 0. I am checking if the input provided above is equal to 0. So if we do this, just to see what happens, it's going to throw a syntax error, because after if, there should always be some sort of expression that evaluates to a Boolean data type, either true or false. So that's why that one's not going to be there. So with that being said, that should give you all of the tools you need. You probably won't even need branching to do this one, but yeah, let me go ahead and end the official class here. If you have questions on homework, do feel free to stick around. I'll say, did you need to say a few more words about this one, Andrea? Did that answer your question, or do you want me to explore it a little bit more?
I was typing in what you were typing in.
Okay.
Like on just a main page.
Okay.
But it wouldn't keep going.
All right, so let me do this.